Okay, in example 5.3, we're asked to find the following indefinite integrals. And so the integral of x to the third plus x, the rule is that you take x, you add 1 to the exponent, so that's x to the fourth, and then you divide by that new exponent. So that's the integral of x cubed. And then the integral of x is going to be x to the 1 plus 1 is 2, divided by 2, and then finally we have to add the constant of integration. And you can check your answer by taking the derivative. If you take the derivative of x to the fourth over 4 plus x squared over 2 plus c, you'll get 4 times x to the third over 4 plus 2x to the 1 over 2 plus 0, and that is x to the third plus x. Okay, so this check worked. When we took the derivative of that indefinite integral, we got what we started with back, x to the third plus x. Okay, in the next problem, we need to take the integral of x to the fourth plus 5 with respect to x. So that will be x to the 4 plus 1 is 5, divided by 5, plus 5. And now you got to think of that as like 5 times x to the 0th power. So x to the 0th power would be x to the 0 plus 1 divided by 1. Okay, so you get x to the 5th over 5 plus 5x. And remember to add the constant of integration. And again, if you take the derivative of that answer, if you get x to the 5th over 5 plus 5x plus c, then you're going to get back x to the 4th plus 5, and the derivative of c is 0. So again, this check worked out. Alright, we have one more to do. Let's do x to the 5th will be x to the 5 plus 1 is 6 divided by 6 minus x to the 4th divided by 4 plus x to the 1 plus 1 is 2 divided by 2 plus your constant of integration. And then we'll do one more check, and that's that if you take the derivative of x to the 6th over 6 minus x to the 4th over 4 plus x squared over 2 plus c, you should get out x to the 5th minus x cubed plus x, and the derivative of the constant is 0. So what we started with is what we end up with if we integrate and then differentiate. So we've checked all three of our answers.